In this video, we are going to solve a system of two equations with two unknowns using the substitution method. There are a couple other methods for solving a system of two equations with two unknowns, and they are called the graphing method and the elimination method. I cover those in other videos, and this video we're just going to focus on solving the system by substitution. So what we're trying to find is a value of x and a value of y that make both these equations true. And the idea of the substitution method is that you have one equation with the variable x and y and another equation with the variable x and y, and these are going to represent the same y value. All right, whatever this y value is here, it's going to be some number. It's the same number as this y value right here, and this x value is going to be the same number as this x value, and it's going to make both these equations true. So since this y right here is just exactly the same as this y, that means that we can substitute into the other equation. Well, I gotta pick a good color here. Let's see. Let's go with blue. All right, so what I'm gonna do here is I'm gonna take this y value. Now this y is equal to x plus 7. All right, x plus 7 is exactly the same as y. So that means x plus 7 is exactly the same as this y right here. Okay. So think of y as like a player, all right? So y is some player on a basketball team, and this is his skills. And I've got this other y in the game, and I can substitute in x plus 7 in for y, all right? They are the same. They do the same thing. They do the same job. I can literally replace this y with x plus 7. So what's that going to look like when I do that? All right. Let's just go to black here. So if I replace that, this equation right here, I'm going to have 1/2 x, right? Still going to be 1/2 x plus, now instead of y, I'm going to replace that with x plus 7. Okay, what's so great about that? What's so great about this equation right here compared to these other two? This equation only has x's in it. All right, this equation has two x's. That's fine. I can combine like terms, and I can solve this equation. Unlike the first equation, this blue equation had infinitely many solutions, right? X's and Y's, and same thing with the red. But now when there's just one variable, now I can solve it. Okay, so that's the whole point of substitution, is once you substitute, you create a new equation that just has one variable. All right, so let's go ahead and solve this. Let's see, what's 1/2 x plus x? Well, this is 1x, so 1 plus 1/2 is 1 1/2. So I have 1/2 x plus 7 equals 1. And then I could subtract 7 from both sides. Now I'm going to go ahead and change this to 3/2 x because I'm going to have to get rid of it here in a second. That's -6. Then I could divide by 3/2, which is the same as multiplying by the reciprocal. So I'll multiply both sides by 2/3. And I get x equals, let's see, 3 goes into 6 twice, times 2 is 4, so -4. All right, or 6 times 2 is 12, divided by 3 is 4. All right, so I have x is 4, but I still don't know what y is. I have to go figure out what y is as well. So I can take this value, -4 for x, and I can put it into either one of these two equations. I'm going to pick this first equation because it was the easiest. All right, so I know that x is -4 right here, so I can put -4 in for x. And that tells me that y is 3. Okay, so now I know the solution to my system is x is -4, y is 3, and we usually write that as an ordered pair. Now you could have picked the other equation. It doesn't matter. Let's say I took the other equation, 1/2 x plus y equals 1, and I substituted the -4 in for this x. I would get 1/2 times -4 plus what is 1. Now that gives me a little more work to do. That's why I picked this first equation, but you know, maybe you like solving equations and you just want to solve as many as you can. So if I add 2 to both sides, I get y is 3. See, I get the same thing. Doesn't matter. Doesn't matter which value or which equation you pick. Oh, my pen's giving me problems here. Are you going to be a good pen or a bad pen? All right, there we go. So it doesn't matter. Now you can check your solution if you want by plugging in the values of x and y and make sure that it makes both equations true. So my first equation, y equals x plus 7. Here's my solution right here. I got y is 3 and x is negative 4. So certainly that's true. All right, that works. Take the second equation and plug in what we got for x, which was negative 4, and what we got for y, which was 3, and see if it makes a true statement. And certainly that is a true statement. So there we go. That means that we have the solution to the system. All right, so let's look at one more example that's a little bit more difficult. Now, before we do that, actually, I want you to notice that when I started this process right here, I substituted x plus 7 in for y because I had y equals x plus 7. What if you don't have something like that? All right, I don't have anything here that's like y equals or x equals. This is my other example we're going to look at. So I'm going to go back and look at this last example. See, we had y equals x plus 7, so I could just put x plus 7 in for y. Here we don't have that. We don't have a y equals or an x equals. So really important, the first thing that you want to do is pick one of the equations, and you need to isolate one of the variables. You have to do that first before you substitute. Isolate one of the variables. So in other words, you need to get either this y by itself on the one side of the equal sign, or this x, or this x, or this y. You literally have 4 choices here. Now, some of those are easier than the others. It'd be pretty easy to get this y by itself. All you'd have to do is subtract the 2x over, right? It'd be pretty easy to get this x by itself because all you'd have to do is add the 3y over. Getting this y by itself, that's not so nice. You want to try to avoid, because you'd have to subtract x and then divide everything by negative 3. So you'd end up with 8 divided by 3, which is, a fraction. Now, if you love fractions, go for it. Knock yourself out. But I'm going to just go ahead and I'm going to isolate this. What happened? I want to do red. I'm going to isolate this x right here. Just because we did isolated y in the other one. It doesn't matter. You can isolate x or y. Okay, so I'm going to add this 3y over. So that tells me x equals 8 plus 3y. Now, I'm going to take this 8 plus 3y and I'm going to put it into the other equation where the x is. And the key there is to put it into the other equation. When I first started doing these, I would always put it into the same equation and everything drops out and it doesn't work. You have to put it into the other equation. All right, so I'm going to really highlight this here. So I have 2 times x. Now x is going to be this whole thing, so I have to use parentheses here. Plus y equals 9. All right, so I took this equation up here, 2x plus y equals 9. I wrote it down here, but instead of writing the x, I wrote some parentheses. So what I'm going to do now is I'm going to substitute our 8 plus 3y in for x. All right, so instead of writing an x, I write 8 plus 3y. All right, you seeing what's happening there? This is an important step. So this equation, I rewrote this equation down here. 2x plus y equals 9. Instead of x, I substituted 8 plus 3y. Okay, that's your substitution step. So that's like your second step. First step, isolate one of the variables. All right, in the previous example, we already had one of the variables isolated. So we didn't have to worry about that. Second step is to substitute. Substitute. That's a lot of T's. All right, so then we're going to, we did our substitution. All right, so step 3 now, you should have an equation that just has one variable in it. In this case, we just have y left. So now we're going to solve our equation that we have. Alright, so I'll distribute the 2, and I get 16 plus 6y plus y equals 9. Combine like terms, so I have 6y plus 1y is 7y. Subtract 16 gives me negative 7. Divide by 7 gives me negative 1. Awesome. Alright, so I find one of my variables here, but remember you have to go find the value of the other variable. So step 4, maybe find the value of the other variable. Now you don't have to go back and do this whole process again. You know what y is. So you can substitute negative 1 in for one of these equations up here. It doesn't matter which one. I'll pick the 2x plus y equals 9 equation. I'll pick this equation, and I know y is negative 1, so I'm going to put negative 1 in for y. So I get 2x plus negative 1 equals 9, and that's going to allow me to find x. So I'll add 1 over. I get 2x equals 10. Divide by 2, I get x is 5. Awesome. X is 5. And y is negative 1. That should be my solution, which we also can write as an ordered pair. And a lot of times you'll see it this way. That's not a very good 5. 5, negative 1. I always like to check my answers to make sure that it's right, that I didn't make a little mistake. So let's go ahead and do that. So I'll call step 5 check. Okay, so 2x plus y equals 9. That's my first equation. Let's make sure our solution works here. So 2 times x, which is 5, plus y, which is negative 1. Does that equal 9? That's 10 plus negative 1. That equals 9. Excellent. Second equation, x minus 3y equals 8. Let's see if our solution works. X is 5. And y is negative 1, and that equals 8. So let's see, that's negative 3, negative 1, that's plus 3. So that is going to give me 8, and that is true. Now, for those of you guys that maybe watched my video on graphing, solving a system of equations by graphing, I did the same exact equations. So if you haven't seen that, that might be kind of interesting. And we got the same solution. So this is another method for finding the solving a system without having to draw all the graphs. And again, this one comes out nice, so the graph came out nice, but if it was a fraction, it wouldn't be quite so nice. So substitution is really going to be one of the most important methods, along with elimination, when you're doing story problems that involve 2 equations with 2 unknowns. And that's really where this is going. Probably in your classes is you're going to have a story problem where you have 2 variables, 2 things you don't know, and you write 2 equations, and then you're going to use one of these methods to solve it. So I hope that was helpful, and good luck solving systems.